Okay, good morning. So I sent the PDF file to your Canvas inbox. I would appreciate if you can just have that PDF file available because writing the questions on the Word will actually take unnecessary time from us. So I sent it to the inbox Canvas. Could you find it? Was it there? Okay, so it means I did it correctly. So please have this handy so that I don't have to write the questions on the board. So let us start with the first question. So that is, I start with a little bit simple problem here today first. So that is problem 2 of this exam 2020, December 15th, yes? So do you see the question now? Yes? Okay. So let x1, x2 up to etc. be IID random variables with xi Poisson distributed, all of them with parameter lambda, for fixed lambda positive, and then for n equals to 1, 2, 3, etc., we write Sn to be, so let me write the information here. So it is given that xi is Poisson distributed with fixed parameter lambda, yes, and then we have actually Sn equals to sigma xi, I goes from 1 to n as usual. We want to compute the conditional expectation E of Sm if Sn for all m greater than or equal to n. Yes? Okay, so the first part is easy. Yeah? So we want to calculate, so Sn is defined to be x1 up to xn, and then they have told us that m is a natural number greater than or equal to n, and then we are supposed to calculate E Sn Sm provided Sn. Yes? Okay, so if you want to do that, let me just remind you a little bit about this notation. If you have two random variables, so if you have two random variables x and y, but what is the meaning of this? Yes, what type of object is this in probability?
Random variable.
It's a random variable. So yes, so even though, so x and y are random variables, so that's a random variable. If it's a random variable, it means that it takes elements from the omega, the sample space, to R, yes? So this in principle is defined in this way. So if this acts on omega, this will give you the probability of x provided that y is equal to y of that omega. Okay, so that's the meaning of this random variable. If you feed it with an omega from the sample space, it gives you this number back, and that's the meaning of being a random variable. And as usual, what is the meaning of this? So if I ask you what is this, it's an event, so it's a set. But this is the abbreviation of writing what? Of writing the set of all omegas in omega. But because I have already used omega, so let me put prime here, so that y acting on omega prime is equal to y acting on omega. So that's the meaning of this random variable. I just play around with the concept. Can this set be empty? Is this set empty or not? It's in this set is the set of all omega primes in omega. Because you know that when I fix omega, y of omega is fixed, is a number. And y equals to that number is a set which as usual defined in that way. So my question, I'm just playing around with the concept to be able to digest the problem. So do you think that this set can be empty? No, well, because omega itself is here, yes, because y of omega is of course equal to y of omega. So that is the meaning of this random variable. Whenever you want to calculate this, my advice for you is that if you want to know what this random variable is, it means that you want to know what a function is. if you want to know what a function is, it is better to know how it acts. So I will start with writing this. Okay, and my thing is that let us say that I calculate this and it becomes a function of y, of course, because y is given, a fixed number, and then you calculate the expectation of the random variable x if y is given. Finally, it becomes a function of y. That's very clear. But then if you have this and you want to write this random variable, yes, then you just simply replace this little y with the capital Y. Yes. So why is that? Because, for example, I have this assumption. So if I want to show that this is the case, I have to show that if this acts on some omega, it will be equal to f of y acting on omega. Yes? What is the meaning of f of y in this case? What type of object is that? F is a function, y is a random variable. So this means that y is also a function. So that's a function composition. So that's a function at the end, and it acts on omega. So if I want to show that this function, which is a random variable, is equal to this function, I have to convince myself whatever omega I choose, the application of this side on omega will give me the application of that side on omega. That's the way that we prove that two functions are equal, yes? Okay, so if I want to show that, so this is my assumption. Under this assumption, I want to show this for all omega in omega. That's my concern. So how should I show that? So E, X, Y acting on omega according to its definition. These are not part of the solution. You can call them theory, you know. I just want to remind you a little bit. So if you ask what is this, according to the definition that we provided here, this is equal to E of X provided that Y is equal to that Y omega. Okay? But now look, if E of X provided that Y is equal to little y by my assumption is equal to F of that little y. So what is the meaning of this? Here, this one is playing the role of that little y. So this becomes F of that little y. Yes? And this is just function composition, so you can write it as F of y acting on omega. So I was able to show that this is the case. So remember, if you calculate this for one particular y, it turns out to be a function of that particular y. This is a number. But if you want to know what the random variable is, what you need to do is just to replace this little y and put capital Y instead. Okay, so that's what you can do. Okay, now let us go back to the problem. So the problem. So how can I calculate this? As I told you, when the question mark for me is this one, of course you can work with the random variable itself as well, but it is comfortable for me if I start with the values of this function or this random variable. So it means that I will calculate this first for some s. So I assume that s is some number, and then I want to calculate this. So how can I calculate this? Sm is the sum from the first term to the nth term, and Sn is from the first term to the nth term, but m is greater than or equal to n. So what I can write, instead of Sm, I can write Sn plus the rest of the terms, xn plus 1 up to xn, provided that Sn is little s. Yes? And then of course instead of this Sn I can put this little s. And then you know that it is linear, So it becomes E of S, but S is a constant. E of a constant becomes the constant itself, plus E of xn plus 1 up to E xn. Sorry. Okay, but all of them are identically distributed. All of them are Poisson distribution with a parameter lambda. Hopefully you know this is very simple calculation. E of xi is equal to lambda. Okay, so how can you calculate this, for example, in the formula sheet? Unfortunately, the expectation values and the variances are not given here. Either you take them with you to the lesson on a A4 paper, I think, something like that you're allowed to take. But if not, you have to calculate it yourself. What is the best way to calculate this if you have forgotten that? Of course, you can start from definitions, but what is useful for you is to look at phi of x for a Poisson distribution. So if x is Poisson distribution with parameter lambda, it should be given somewhere. Yes, you can check it. I think it is somewhere given, yes or not. Yes, Poisson is given, and this phi of x, the characteristic function is given to be e to the power of this lambda, eit minus 1, yes? And then how can I calculate ex using characteristic function? Do you remember? Yes?
You can differentiate with respect to t.
Yeah, so let me write it here for you. So if I want to find every moment here, and then this one to power n, I to power n times expectation value of x to power n is equal to the nth order derivative of the characteristic function calculated at 0. Okay, so this is a good formula to remember or take notes for you. So, and then you need to calculate this, but I want e of x, so the best thing I can do is to calculate e of x, and I is equal to the first derivative calculated at 0. But then I can calculate phi prime x here. So the derivative of this expression, so the function repeats itself. But I have to multiply by the derivative of the exponent, which becomes lambda I e to power I t. Yes? And then I put 0 instead of t. So this becomes lambda I, and this becomes 1 minus 1, 0 e to power lambda I. So this means that I, expectation value of x, is equal to lambda I. So some of you might even have it in your memory. I'm not sure that if you're allowed to use it just because you remember it or not. But anyway, e of x for all Poisson distributions is lambda. Okay, so this means that if I go back here, so that if I put this as a question mark, and if I give this a star, so from this star, the question mark becomes equal to s plus all of them will be lambda. But how many of them are there? So it becomes lambda plus lambda. But how many of them are there? The lowest index is n plus 1. The highest index is m. So how many of them are there?
M minus
M minus n. Yes? The last one minus the first one plus 1. Yes? So the last one minus the first one plus 1. This is the number of terms. Yes? So it becomes m minus n. So it becomes m minus n factors. Then it becomes s plus m minus n lambda. So what is this? This is this expression that I calculated. Okay? So this is what I was able to show. But the problem asks you about this random variable. According to this rule, if I calculate this and it turns out to be a function of y, the only thing I have to do is to replace this little y by the name of the random variable associated with that. So what can I do now? So this becomes e sm sn is equal to what? This S is the value of this random variable, but I want to go from here to here. According to the rule, I need to pick up this S and replace it by the name of the random variable, which in this case was S sub n. So this becomes S sub n plus n minus n. Of course, you can also work with this one itself. It depends which one is suitable for you. But sometimes I get confused. This way I will not get confused. If I calculate it at a number, then according to this rule I go back there. Yes? Is that understandable? Okay, so now let us go to the next part of the problem. Show that Sn, so you have, hopefully you have this paper, yes? I send it to your inbox. Please have the PDF handy so that you can see the questions. So show that Sn minus lambda n divided by square root of Sn converges in distributions to a normal distribution with mean 0 and variance sigma squared as n goes to infinity. And of course, you are supposed to determine the value of sigma squared. Make sure to explain your reasoning. Okay, so this is the expression given, Sn minus n lambda divided by square root of Sn. Yes? So we want to show that this in distribution becomes a normal distribution with some unknown variance yet. We are supposed to first show this and of course to find that sigma squared. I hope that you are familiar with these kind of things. Which theorems might be relevant here? Two main theorems, one CLT and the other one LLN, yes? So let us review the content. So if I want to write the LLN theorem, so what is LLN? Tells you that Sn divided by n. Of course, for the conditions for LLN and CLT, you need to know that xi's are independent and identically distributed, which in this case it is. So this goes in probability to the mean of that random variable x collectively, yes. So that is why all of them should be identically distributed, and this mu of x is the mean of one of them, in other words, all of them. Okay, and then you have CLT theorem. Under the same condition, what do you have? You have Sn minus n, the number of random variables, multiplied by mu x divided by sigma x square root of n. This goes in distribution to n, 0 and 1. Yes? But do you remember I told you it's better to write it slightly different. It's better to get rid of this sigma x. If I multiply everything by sigma x, you know that sigma x will be squared and flipped in. So this means that I have, let me write here, I will have, and I factor n out, yes? So this becomes Sn n minus mu x and divided by square root of n. This goes in distribution to n, 0 and sigma x squared. Yes? But of course, n divided by square root of n can be written as a square root of n. So this form is also good to remember for problem solving. So this also goes in distribution to n, 0 and sigma x squared. That's the same CLT theorem written in a slightly different way, which is sometimes suitable for us because, you know, this becomes very similar to this LLN theorem. This minus that one is part of this. So it's better to see it in this form. Okay, so now what is your recommendation here? I want to have this convergence in distribution. So you see that this is somehow similar to this one that we want. But of course, in the denominator, instead of having square root of n, I have a square root of Sn. So what should I do? I will start from here. So can you tell me what to do? Lambda. In this problem, what is, in this problem, yes, in this problem we have n lambda divided by square root of Sn. So what I will do, I factor an n out, Sn over n. minus lambda, and then divided by, here, what do you think I will do? Because if you have experience, you want to use convergence in probability in the denominator. And for using convergence in probability, you need n below Sn. So this motivates you to write Sn over n, but you are not allowed to change the problem, so you have to multiply by square root of n. So far I have done nothing, yes? I have just reformed the expression in a form that I can use my formula somehow. But n divided by square root of n is just nothing except this. And this one is just Sn. Okay, so now according to LLN, what we know that Sn over n goes in probability to mu x. In this case, mu x is lambda. So what does it mean? It means that the square root of Sn over n, this is valid in the distribution in probability, yes? Why is that valid? Of course, you have to explain in the exam. Well, what is the condition that I need to draw this conclusion?
Maybe also that they are IID and that they're
No. Just taking the square root. So
it's it's
continuous. It should be continuous. So this function square root of x is continuous at lambda because lambda is positive. Yes. So you have to explain this in the exam that why you are allowed to take a square, because this is the real form of LLN. But now I want to motivate that why I'm allowed to take square roots from both sides. So, and that happens if this function is continuous at this number lambda. And this is the case because lambda is given to be positive. So this is one thing I know. And the other one, according to CLT theorem, the square root of n, Sn over n minus lambda goes where? Goes to n sigma n, 0 and sigma of x squared. Okay, so if you want to calculate sigma of x in the exam, if you have written it down, so of course you can use it, but otherwise you have to calculate e of x squared, and this will be I squared, and then you take the derivative 2 times and then replace it with 0. If you do that, you will get ex squared, then the variance will be the difference between ex squared and minus ex to power 2. Okay? Do you want me to go through it or not? Do you know it? Okay. So this means that if you do the calculation, it becomes lambda squared. Lambda squared or lambda? Let me see. Of course, it should be lambda squared or lambda. No, it is still lambda. So remember, we can remember now that the mean and the variance of the Poisson distribution, both of them are equal to lambda itself, the parameter. So this is CLT theorem. But now I need to use this Kramer-Slutsky's theorem. Yes? So this denominator goes to square root of lambda in probability. Yes? And then the numerator goes to distribution in distribution, goes to this in distribution. So by Kramer-Slutsky theorem, what can I conclude? I can conclude that this expression is square root of n Sn n minus lambda divided by square root of Sn n goes to, so I multiply this by 1 over square root of lambda. So yeah, it's a little bit sloppy notation. Yes, but I can also flip this in, but I have to square it. So this becomes yes, is that okay?
Shouldn't we show it
sigma 0 sigma squared.
in the problem formulation?
What?
According to the problem, the result should be sigma squared instead of 1.
What is sigma squared then?
It's 1, so it's the same.
Why is it 1? It's
No, it is
excisor
not written.
colonial.
It make sure to explain your reasoning. So determine value of sigma squared. So we determine sigma squared is 1. Is that right? Or I'm missing something? Because sigma was not something given. Yes, I cannot end up with sigma squared. So I ended up with this, and then they are asking what is sigma squared. You have to answer sigma squared is 1.
Oh, okay, yeah.
Is that right?
Yes.
That's at least my understanding. Okay. Okay, any questions understandable here? Okay, so let us go to the next problem. This is problem 3 of exam 2020. So we have two random variables x sub 1 and x sub 2. So we have these informations. We know that x2, provided that x1 is equal to x1, is normal distributed with mean x sub 1 and variance 1. And you can see that x1 is normally distributed. We want to compute x2. So let me write this information here for you. Okay, so we know that x2, provided that x1 is x1, is normally distributed, but with mean this little x1 here and the variance 1. We also know that x1 itself is also normally distributed with mean 0 and variance 4. Okay? We are supposed, part A, we are supposed to find this expectation value. Yes, is that right? Yes, we want to find this expectation value. So how should I calculate this? So you know that the given distribution is conditional. So it motivates you to use the conditional expectation value for this one. Okay? So one way to look at it is to write E of what? E x2 provided x1. Yes? So that's a very famous formula. It's always valid. So do you remember that I just told you that this is a random variable and it makes sense to take expectation value of a random variable? It becomes a single number. At least they fit together. Yes, the right hand side is a number, the left hand side is the number. This theorem, which is called the total expectation formula, it makes sense. Okay, so if I want to do that, why I was motivated to start from this formula? Because in principle, if you want to calculate expectation value of x squared, you in principle can do that. Yes. Without this formula, you have to write the integral of x2, but you need the marginal distribution of x2. That's also not wrong, but it might be a little bit longer to calculate. But whenever the information given to me is conditional, and I want to calculate something without condition, it's always good to think about make conditions on it. At least this is one mindset to have when you want to calculate this. Okay. In order to answer this question mark, I need to know what this guy is. Okay? And this is exactly what I told you here. So for me, it's always simpler. Of course, in this case, it is so simple you can also work with the function itself. But let us not change the strategy. Okay? If I want to calculate this, I usually prefer to ask myself, what is this? Okay? And calculate it for some single choice for x1. Okay, so how can I calculate this? So in principle, a definition tells me that this is the integral of x2, but what? The conditional distribution calculated at x2, dx2, and then it goes from minus infinity to infinity. I don't want you to calculate the integral, I want you to understand what is the meaning. So instead of this one, what I can write, do you understand that? This is the definition of this expression, okay? And in order to continue, I need to know this function which is given to me, and that is this distribution. So by a little bit sloppy language, instead of this, I can write this one. And if I ask you what is this, this is the function, distribution function for this normal distribution here, imagine. And then you are multiplying by x squared and you are integrating over x squared. So this will give you the expectation value of x squared under this distribution. Is that right? Understandable or not? Yes? Okay, so what's the answer? You already know the answer. So this gives you, so you see, in principle, instead of this, I have to put this distribution function. What is this distribution function? By the way, can you write this one for me? So if x has this distribution, okay, what is this? What is the expectation? What is the probability density function for this? This becomes 1 over sigma, which is 1, square root of 2 pi, and then you have e to the power of x minus the mean squared divided by 2 multiplied by a minus sign. That's the function I have. And when you put this here, when, of course, here, because this is x2, I have to write x2 here, sorry. Yeah, so let me write like this. So this means that this function, I have to put it here. And what you see expectation value of x2. And the expectation value of x2 is x1. Yes? Is that clear? This is, I hope that you understand and you are not confused. If you are, let me explain again. And everyone okay with this? So this one that I have written here is the definition of this. I have written it here, but I already know what function is this function. This is this distribution. And I am calculating the mean of x squared, x sub 2, if the distribution is this one. And I know that this will give me the mean of that distribution, which in this case is x1. Okay? So what I calculated here, e x2, x1, x1, so is equal to x1. Now can you tell me what is e x2 provided x1 now? According to this rule I told you. You see that the value of this is equal to this x sub 1. So whenever you get something, if you want to go backward, you need to replace every little x1 with the name of the random variable. So this is just simply x1. Yes? And now I put it back into this question mark. Yes? So this means that the question mark of the problem, which is ex squared, x sub 2 is equal to e, but then I put x1. Is that right? So instead of this expression, I just put x1, so this becomes e of x1. But e of x1 is what? 0. Okay, so that's the first part of the question. Yes? So now if we go to the second part, we want to explicitly determine the density of the random variable x, vector x, and find the distribution, the probability distribution of this random vector. Okay, so what we have to do, we want to calculate f of x1, x2, calculated at x1 and x2. So where do you think I will start from? So this is part B. So this is what we want to calculate. So how should I do that? Yeah, exactly. Write the definition of this one. So you have f x1 provided that x2 is equal to x2 calculated at x1. Yes? Oh, sorry, the other way around. 2 x1, x1 calculated at x2 is equal to what? F x1, x2, x1 and x2 divided by f sub x1 of x. But the numerator is your question mark, so it is very simple to see that if I want to find my numerator, so let me write my question mark becomes equal to the product of these two. So this becomes f of x2, provided that x1 is equal to x1, calculated at x2, multiplied by f of x1 at x1. Yes? And all of them are given to you. So what is this one? This is this normal distribution, so it becomes 1 over sigma is 1, so it becomes square root of 2 pi. And then I have exponential minus 2 times sigma squared. And then I have my x2 minus x1 squared. Yes, if I make a mistake, please let me know immediately. Do you agree with what I have written here? So this is the first one. And then you multiply it by this one, so which becomes 1 over the square root of 2 pi. In this function, so I have a 2 here. So sigma squared is this one, so sigma is 2. So I put a 2 here, and I have also a square root of 2 pi. And then I have exponential minus x1 squared divided by 2 times 4, which let me write 8, yes. Because for the next part we have to calculate a little bit, so it becomes this one times that one times 2 is 4 pi, and then I add the exponents. So when I want to add the exponents, if you don't mind, let me factor a minus 8 out, and then this becomes a 4 x sub 2 minus x sub 1 squared plus x1 squared. And then let me open it up, so it becomes 1 over 4 pi, exponential, I have minus 8, this one to power 2, so it becomes 5x1 squared, 2 times the first one times the second one, minus 8x1 x sub 2, and then this one to power 2 times 4. Yes? So that is the answer to this part, and they are asking you to calculate, if you go here, you have to calculate the characteristic function f sub x, okay? So we want to calculate the characteristic function for this distribution. So what should I do here? That formula is not here, so I think it is better to take it with you because I don't see that formula here. So do you remember, if I have a normal distribution, is it guaranteed that this is normal distribution yet? Yeah, of course, if you're familiar with the form, you already know that this is actually a normal distribution. But even if that is, you need to know lambda, you need to know the covariance matrix so that you can put it in the distribution function for the normal function. So if I want to do that, I have to write this in a form that's appropriate to understand what lambda is, the covariance matrix is. So let me continue this a little bit. So this becomes 1 over 4 pi exponential. So what should I write here? Do you remember, I told you, remember, this is a very famous combination. You can write it in the form of a matrix. But I need a factor of minus 1 over 2, do you remember? I put a minus 1 over 2, there is 1 4 left here, so remember that. I will write it as a matrix x1, x2, multiplied by, I put a 1 over 4 here. You see, because I had 1 over 8, so I split it into 2 parts, minus a half, because I want to compare it with my formula, and then I put 1 over 4 here. Which matrix I should write here, do you remember? I put 5 and 4 as diagonals. Okay? And then half of this number here and there. Yes? And then I write this column vector x1 and x2. it's important to, it's good to remember this formula. So if you remember, the formula is this, yes? ax squared plus 2bxy plus cy squared can always be written as x and y times a, b, b, c times xy. It's good to remember this combination. It's very simple. You just multiply those three matrices, you see that you will get this number back. But if you have it in your memory, at least you can go backwards as well, something like this. Okay, but do you remember, if this is going to be a normal distribution, so this should be what? A lambda inverse. Okay, so this means that, by the way, is it a normal distribution yet? Yeah, but we have to be also careful about the coefficient. So we have to confirm that the coefficient has also the correct form. What is the correct form? For two variables, it is 1 over 2 pi multiplied by square root of the determinant of the covariance matrix. Yes? So the coefficient is for n variables, it's 2 pi to power n over 2, 1 over square root of determinant of the covariance matrix. That should be the coefficient. Okay? So for the time being, I'm not sure that this has the right coefficient. Of course, I know the theorem, it should be, but let us pretend that we don't know. If this is going to work, this should be what? This should be lambda inverse. So if that is the case, then lambda inverse becomes that matrix. So I need my lambda. So lambda becomes inverse of this matrix. So this becomes 4. Multiplied by the inverse of this is 1 over its determinant. Determinant of this matrix is what? 20 minus 16 is 4. So it becomes 1 over 4 times the adjoint matrix. The adjoint matrix for 2 by 2 matrices is very simple. You just replace these main diagonal entries and then multiply these by a minus sign. So 4 and 4 cancel, and then I have 4, 4, 4, and 5. Okay? And then so let me now write this coefficient to see that if I have the correct form. So the coefficient is equal to what? 1 over 2 pi. I have 2 random variables, so 2 over 2 is just 1. What is determinant of lambda? Determinant of lambda is 4. So it becomes 1 over the square root of 4, which is 2. And then I get exactly that coefficient. So everything is correct. So this means that this can be written as 1 over 2 pi, 1 over the square root of determinant of lambda, and then multiplied by exponential of minus a half. This one I can write vector x transpose or prime, as in your book, multiplied by lambda inverse multiplied by x. So I was able to show, yes, this distribution has this exact form. So now I can guarantee that, yes, this distribution, this vector is indeed normally distributed. And if it is normally distributed, then I have a formula for phi of x. It's better to today just fill up which formulas you need to take with you, okay? Because this is not here, but this is needed. So what is the formula? For a normal vector, if I want to find a characteristic function, it is exponential. You have I times a vector mu x. This is the mean, and then multiplied by, I have to write T inverse here, sorry, T transpose. T transpose here, and then plus or minus 1 over 2 T transpose lambda T. So this is the formula that for this problem you need to know, and it is not in the formula sheet. Yes.
Just one thing about that. It's not in the formula sheet, but they do have the single variant equivalent, and it's really easy to go from that one.
Yeah. That's up to you. Yes. Yeah. Yes, of course. Okay, but in this case, in our problem, what is this vector? Vector mu here. It's not given in the beginning because we didn't even know that this is going to be normally distributed. You have to read it from here. So you know that if there is a vector mu, what appears here is minus mu1 minus mu2. And there will be also minus mu1 minus mu2. But this was not the case, because when I solved this problem, I got this, and I don't see mu sub 1, mu sub 2 are not there. When they are not there, it means they are 0. Okay? So this means that this vector is the 0 vector, so I don't need to be worried about that. So what I will do, just write exponential minus 1 over 2. So T transpose means T1, T2 is a row matrix. And then this A I calculated there, so it is 4, 4, 4, and 5. And then I have T1 and T2. So that is your characteristic function. Now I think using the same formula here, you can write it more explicitly. So it becomes exponential. So what do? You have a minus over 2 here. So that's a factor of minus over 2. But this one I have it in my memory. So what's the answer? So it becomes 4t1 squared, and then 2 times this coefficient, which is 8t1, t2, and then finally 5t2 squared. Yes? Can you always check my answers? Yes, is that right? Okay. Yes. Is there any questions here? Yes?
I didn't understand why we did all the reasoning about the coefficients of this calculation of the distribution.
Okay, the reason is I wanted to use this formula.
Okay.
This formula is only valid for normally distributed random vectors. So I have to convince myself that this is indeed a random normal vector. So in order to do that, I am comparing the formula for the joint distribution with the formula that I have for the general normal distributions. And for those cases, the coefficient should read like this.
This is a fixed formula.
Yes. So yeah, so if you want, I can write it. So if you have this, if x has n components, this is actually the second or the third definition of normal random vector. So it is 1 over the square root of determinants of the random. So it might be that's also good to take with you to the exam, because it is not in the formula sheet. So what was that? It was exponential, and then you have minus 1 over t, 1 over 2, and then you have vector x minus vector mu multiplied by lambda squared. This is transpose, of course. Yeah, that's the formula. That's the general formula for the distribution of a random normal vector, which is normal vector. So in order to make sure that this is indeed the normal distribution, I have to convince myself it fits to this formula. Okay, so the coefficient to be of this form matters actually. Otherwise, I am not allowed to use this formula, because this is only for the normal vectors. Yes? Yeah.
Yeah. The question says explicitly compute the characteristic function. So, like, we don't need to use the definition, or like we could just use this.
I haven't read that. So explicitly, how they have solved it? Did they really calculated everything from scratch?
I have not checked, but like.
Yeah,
when
can
I
you
read
see
this,
that?
I feel
I
like,
could check.
Yeah, it's always better to check. Thank you very much if you can help me.
yeah.
Okay, so now let us go to the next one. So this is exam 2020, October 16th, yes? So as you see on the display or in your display, so you see that we have given a vector x, which is normally distributed with mean vector 0 and covariance matrix as you see here. Explicitly determine the joint probability density. By explicitly, they mean that don't leave it as vector 4. So might be that's the meaning of explicitly here. Now, because you know, in principle, I could have left it in this form.
Yeah.
Yes? So this is not explicit expression. So you open it up and write it as this polynomial, then you call it explicit. At least that is what I understand now.
Very smart.
Yeah. Okay, so now explicitly determine the joint probability density as you see it on the display, and they have given you a hint, which is a good one. Before diving into computations, use the structure of lambda. So what is the structure of lambda? Can you see that? What is that? So it is block diagonal. So if it is block diagonal, it means that the random vector with components x1 and x2 and the random vector with component only x3 are independent. Yes? So, okay. So let us now go and then calculate this. Pardon? Yes, yes. I think I can pause a little bit here. Okay, so the first one we want to calculate here. So you see that they have given you a hint. Of course, I don't think it should be extremely hard if you don't recognize the hint, but this is a block diagonal one. Are the numbers written correctly? Yes. So that's a block diagonal lambda. So this means that the vector x1 and x2, which is the first block, is independent of the last block, which corresponds to x sub 3. Yes. So this, what does it mean? It means that if I want to calculate this joint density function, I can write the group of the first two joint density multiplied by the last one. This is because of this structure. Okay, but you know that if this is normally distributed, each joint probability distribution is also normal. That's one of the theories. I mean, that's mainly the first definition. Okay, so I have to calculate this and I have to calculate this. This one is extremely simple. So let us start with the simple one first. Okay, so remember that this is the vector. Of course, they have written 0, but this is the 0 vector. So it means that the mean of each one of these random variables is individually 0. And we know that this should also be normally distributed. So if I know that is normally distributed, I need to just write a formula for it. So it becomes 1 over sigma. So what is sigma here? It is 2, yes? So it's a square root of 2, sorry. And then multiplied by square root of 2 pi. Because this number, these diagonal ones are variances. So variance is sigma squared. Okay? But what you want to write here is sigma itself. So you take square root. And then you have exponential. What should I write here now? For x3, I have to write minus 2 times sigma squared, which is 2 times 2. And then what is the mean? The mean is 0. So I have to write just x3 to power 2. This is the first one. It's very simple. Yes? But if I want to do for the first two, this means that, I don't know how should I write it, but let me write y, the vector y is x1 and x2, so let me calculate the covariance of y. So what is covariance of y? If y is x1 and x2, is just this 2 by 2 matrix. Okay? So what do I need? I of course erase the formula there, but what you need determinant of this, which is 4 minus 1, 3. You also need its inverse. So it becomes 1 over the determinant. You replace them, in this case doesn't matter, and then you multiply them by minus 9. Yes? And then you have to use that long formula, do you remember? So if I want to write it now, f x1 and x2, x1 and x2. It becomes 1 over 2 pi 1 over square root of the determinant. So square root of determinant is square root of 3. And then you have exponential minus a half. And then you have x1, x2 multiplied by lambda inverse, which is 1 over 3. If you don't mind, let me make it 1 over 6. And then I have 2 minus 1, and 2. And then multiplied by x1 and x2. Yes? So let us simplify this a little bit. So this becomes 2 pi square root of 3. And then this becomes exponential minus, I have a 6 in the denominator, and then I told you that you see that this formula appears a lot, so I would write 2x1 squared minus 2x1 x2, and then plus 2x2 squared. And then, if you don't mind now, let me simplify everything by 2. If I simplify everything by 2, this will be 3. And then you just multiply them. So let us skip that, yes? So the answer to the question mark is the product of this one with that one. And then, of course, you can combine exponentials by adding the exponents, yes? Is that right? You can continue this yourself. But what is part B? Part B is asking us to calculate this. Plus 3 and then x2. So how should I calculate this? Yeah, open it up, it's linear, so it becomes e x1 provided x2 plus e x3 provided x2. Okay? Sometimes we can go a little bit further. So for example, what do you think will happen here? This is expectation value of x3 provided I have some information regarding x2. Yes? But what was the relation between x2 and x3? They were independent. If they are independent, what does it mean? It means that knowing or not knowing x2 doesn't have any change, doesn't have any effect in the expectation value of x3. So because they are independent, so I can write it as ex3. Yes? But what is ex3 in this problem? E of all of them is 0, because that is the 0 matrix. So this is just simply 0 because of this problem. So what I need to do is to only calculate this one. So this is what I need to calculate. So how should I calculate this one? Again, that's the same structure. I prefer to calculate it like this. But that's up to you, of course. So how should I calculate this? Using the definition. Yes? So how should I write this? It becomes integral of x1, but I have to write probability distribution x1, x2 is equal to x2 of x1, dx1, and then x1 goes from minus infinity to infinity. Yes? Yes? But then I have to calculate this one. So in order to calculate this, I have to write its definition. x1, x2 equals to x2, x1. This becomes the joint probability distribution. Yes, calculated at x1 and x2 divided by f sub x2, x2. Yes? Okay, the numerator is exactly this expression that I have it, but what is the denominator? Okay, that one was not the one I calculated. I need to calculate this one as well. But can you tell me what is fx2? So let me write it here for you because we can do it here. So instead of the numerator, I put this expression. I have calculated this one already. So this becomes 1 over 2 pi square root of 3 exponential of minus, then I have x1 squared, x1, x2 plus x2 squared divided by 3 divided by this So we know that this should also be normal, and we can read the information from its own covariance matrix. So what is that? That's a normal distribution. What is the mean of x2? Is 0. What is the variance of x2? Is 2. Yes? So this becomes 1 over variance is 2, so this will be square root of 2, square root of 2 pi, and then I have exponential of minus, what should I write here? 2 times 2, yes? And then in the numerator I have x2 squared. Do you agree with me? Yes? Okay, and then if you don't mind, let me write this 4. And let me simplify this a little bit, so this becomes square root of 2, square root of 2 pi, divided by 2 pi, square root of 3. And here I would write exponential. I bring this with positive sign up. So if I haven't done anything wrong, this should also be a normal distribution. Let us check that. So what happens? This becomes the square root of, so let me write it like this for the time being. Yes, this one and that one, I can write it in this form. I copy and paste these two. But let us see what can I do here. Is there something we can do here? For example, let me factor 1 over 12 out. So then I have to multiply everything by 4. And then this one by minus 3. So this becomes 4. So I factored minus 1 over 12 out. So I have to multiply the numerator by 4. Yes? 4, 4, 4. But this one I have to multiply by 3 because I factored a minus sign minus 3. So they will simplify to this. Yes? Yes?
It's maybe a stupid question, but like we know that x1 and x2 is like covariant of x3, but how do we know they're like independent? Because I know that independence implied that it's covariant is 0, but not the other way around. Or
No, what I am using is that if a vector, if a random variable
yeah,
is independent from this as a vector,
yeah.
it will be independent from each component. Yes,
Okay.
it is not trivial, but I can justify it later for you.
Okay.
Yes, I'm using that. You are right. Yes. So in principle, what I know this as a random vector is independent from x3.
Yeah.
But it is not hard to show that x3 then becomes independent of each one of the components as well.
Okay.
Yes?
But it was more like if just x1 and x3.
Yes?
If x1, if covariant x1 x3 is 0,
Yes?
does that imply it's independent?
No.
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 Yeah.
No.
No. Okay.
But if they are normally distributed, yes.
Okay. Okay. So,
Yes. Yes.
I see.
Okay. So now, do you agree with my calculation here or not? Yes. So I factored minus 1 over, if it is hard for you, just multiply and simplify. I don't think I have made a mistake. So I factored the minus 1 over 12 out. So this means that I have to multiply every one of them by 4. I have to multiply this by minus 3. And then I did some simple algebra. This is 4, minus 3 is just this one. And that's good, because I was a little bit suspicious that if this is going to be a completely squared. But is it? So it becomes 1 over, I would write it the square root of 3 over 2. Do you know why I'm doing these things? Because I want to make it in the standard form of a normal distribution, so I need to have my sigma here. So this becomes exponential. And this one, if you don't mind now, let me factor another 4 out, because I want to have this one out. So it becomes minus a third. And then I have x1 squared minus x1, x2 plus 1/4. So it becomes x1 minus x2 divided by 2 squared. Yes? The first one squared is x squared. 2 times the first one times the second one is, so if you don't mind, let me write it for you. I factor a 4 out from here. So this becomes x1 squared minus x1, x2, and then x divided by 4. Yes? And then do you agree this is exactly this expression? Yes? The first one squared. 2 times the first one times the second one squared. That's correct. So now, so I was able to calculate this expression. So what kind of distribution is this? Definitely it is normal distribution, but can you tell me what kind of distribution? What kind of normal? By the way, do you know that why I decided to factor 4 out? Because this one was also a complete square. Why didn't I write it like this? I should have explained, I was thinking why. So this is already a complete square, so I can write it as 2x1 minus x2 to power 2. Do you agree or not? That's the same thing. Why I made trouble for myself to factor the 4 out? Right? So these things you need to know, because then you will be lost in the exam. Yes? So you have to know why. Because this is a function of x1, and I want to make it normal for x1. If I want to make it normal for x1, the coefficient of the variable, which is x1 in this case, in the standard distribution should be 1. So that is the motivation why I make the coefficient of x1 squared 1. Yes? Because this is a function of x1. Okay, so can you tell me what is this? What is the mean? The mean should be easy for you to read if I haven't done any mistakes.
x3 divided by 3.
Yes, this number here is the mean, yes? So it is x squared over 2. But if I haven't done something wrong, this should be my sigma. How should I understand this is indeed the sigma? Because the standard one, it would be 3 times, so it should be, so how should I write? Let me write it for you. So then it becomes 1 over square root of 3 over 2, because I want to make it a standard normal distribution, so it becomes exponential, and then what I have is minus, in the numerator I write it here like this, and in the denominator I don't need 3, I need a factor of 2 in the standard distribution, times sigma 2. But this is not 2, this is 3, so I have to compensate for that by writing as 3 over 2. Is that right? So now that is exactly the normal distribution. This is sigma squared, which is fine, because if this is sigma squared, this is sigma, and everything is. So what can I write now? N of, what was this? This is x2, sorry. So it is x2 over 2 and sigma squared, which is 3 over. Do you agree? So that is the distribution of this function here. So if I go back here, so therefore what I can conclude that E x1 with respect in the condition that x2 is x2 is this expression. Yes, that is what I calculated that. Okay, I have to put it in this form. So it becomes integral from minus infinity to plus infinity x little x1 multiplied by this distribution function, which was this. So if you don't mind, let me abuse the notation a little bit so this becomes that. Are you following? Is that clear? Okay, what's the answer? What is the answer to this problem?
0.
No.
No.
Did you understand what I did? So you see, so let me just review quickly. I wanted to calculate this. I used linearity, wrote it like this, and then x2 and x3 are independent. So instead of calculating this, I can calculate this, but this is given to be 0 because all of the means are 0. So the only problem that I have is to calculate this part. And as I told you, my advice for you is that, not advice, that's up to you, of course. I always calculate the values and then go back to the random variable itself by the rule that I told you in the very beginning of this lesson. Okay, so if I want to calculate this is the definition that I have. So I have to know what I want to calculate. They have definition. I put it in this definition. And then I realize, okay, in order to answer this, I need to know that. In order to calculate this, I need its definition. I put the definition here and put the information from the problem and the one that I calculated before here. Did some algebra. I realized that this expression is this distribution. Then I go backward and calculate this one. So it means that instead of this expression, I can write this expression. Yes? Do you agree with me or not?
Yes.
If I ask you, so what is this? This is the expectation value of x1 under this distribution. Expectation value of x1 under this distribution becomes the mean of the distribution, isn't it? What is the mean of distribution here? x2 over 2. It doesn't mean that you have to think in this way. Of course, you can sit down and calculate this integral, but that is a bit not a very efficient way. It's better to understand what is the meaning of this integral, and you already have the information to put it here. Yes? Okay, now can you tell me what the question mark that I was looking for? So therefore, what can I write for x1 provided capital X2? That was the first rule I told you. I calculated this one. It became x sub 2 divided by 2. To go backward, the only thing I have to do is to replace little x2 capital X. So it becomes what? Is that right? So the question mark, now the final, so therefore, E of x1 plus x3 provided x2 is what?
Yeah, like during the exam, don't we have to like actually calculate that?
No.
Just
Calculation of that, you need to know Gaussian integrals.
Yeah, okay.
Yes.
Okay. So what do we like write to motivate that?
Yeah, that's the definition of expectation value of this random variable if the distribution function is this. So in principle, if I ask you what is this, so when I say ex, how do you interpret it, ex? It is integral from minus infinity to infinity, x, and then fxx dx. Yes? Usually, you have to calculate this integral to answer ex. But if you already know ex, you can calculate the integral. So that's the other way around. Yes, is that right? Any questions? Okay, so let us... Yes.
Does this only apply for normal distribution or every type of distribution?
No, every type of distribution. If I show you this integral, you know the logic. Usually they ask you to calculate the expectation value. You put it in the formula and calculate the integral, you will get expectation value. Okay? Here, I know what is the expectation value of this random variable because I know so you know if I ask you what is this, it means that you take this off and you put the distribution for a normal distribution with these parameters in and calculate this. So it will give you the expectation value of your random variable. This we know. But on the other hand, I know what is the expectation value here. It is written here. That's the answer. That's my logic. Yes, please.
So basically, you didn't actually write it, because you just said that it's normally distributed.
Yeah, exactly. Yes. Okay. because the reason that I think in this way, because there are a lot of information there. So there are some limited information I remember and memorize, and hopefully I can derive them. I think this is a better way, because if the course is very extensive, and then you get confused, you don't know. So you need to have some ideas and always start from there. Because, for example, I don't think that this is acceptable, because for these calculations, there are formulas given in the book. So I don't know if you take those formulas with you and put the numbers in, he will accept it from you or not. So that's the idea of taking one piece of paper to the exam is a little bit vague idea, isn't it? Because it depends what you want to do. Okay, so let us go now to the next one. This is exam 2020. It's a little bit better question, I think. Problem 3 on exam 2020 is October. So let X be the standard normal distribution, normally distributed with the standard distribution, and they have introduced Z to be e to the X. Part A of the problem, which we concentrate first, determine the probability density of Z. And I don't know what that hint is. Note that Z equals to e to the X is non-negative. So of course this is not something very strange. Okay, so let us now go to the problem and try to solve this. So you see, we know that X is normally distributed with mean 1 and variance mean 0 and variance 1. And then they have introduced a new random variable that is e to the X. And you want to find the probability density of Z. So what is wanted? Density of Z. This is what they want. So there are two ways usually to calculate this problem. What are they? First, you start calculating the capital F and then differentiate to find little f. This is very standard way. Yes? There is another way, which is the transformation theorem. That's also valid. So that's up to you in which way you want to calculate. So let me start from the very beginning. So if I want to calculate this, first I calculate the distribution function, for example, and then I have to remember the definition of this. So what's the definition? It's the probability of what happens. This capital Z becomes less than or equal to this Z. Instead of capital Z, I can put this is less than or equal to Z. And be careful, Z is allowed to be any real number. So you have to sometimes discuss about the situation. So one possibility is that Z is 0 or negative. In that case, what will happen? So this becomes equal to 0 if what happens is Z is less than or equal to 0, yes? Because this cannot happen. E to the X, might be that's the reason that they have mentioned that this is non-negative. So Z is less than or equal to 0, the probability of this thing to happen is 0. Do you agree? There is another alternative. What happens if Z is positive? If Z is positive, then it becomes a probability of X less than or equal to ln of Z if Z is positive. Do you agree? I wanted to take ln from both sides to transform this into something related to X. But then I realized I will be in trouble if Z is negative, because ln of Z is not defined in that case. It motivates me to break the problem into two parts. I would say that if someone tells me Z is 0 or negative, I don't need to calculate anything. The probability of this to happen is 0, because e to power x is always positive. But now, if Z is positive, now I am on the safe side. I take ln from both sides. ln of this one is X, ln of this one is Z, and it is well defined here now because Z is positive. So it motivated me that I have to break the problem into 2 parts. Okay, but then I have to calculate this one. But that one is also simple, yes? What is that? Because I already know the distribution, and I want to calculate this probability. So let me calculate this one. So z is positive. Let us calculate this. But this is a very standard problem, yes? What happens? It becomes integral from where to where? Because this is a normal distribution, it means that x can go from minus infinity to infinity. So if you can draw a diagram for yourself here, this is x from minus infinity to infinity. And then ln of z is a number, is somewhere here, for example. And you want to have x less than ln of z. So you have to integrate over all possible values. Yes, so it means that I have to go from minus infinity up to ln of z of my normal distribution function. So it becomes 1 over square root of 2 pi, and then e to the power of minus x squared divided by 2. Okay? So let me ask you some questions that you don't fall asleep. So what should I do now? Because first of all, you have some experience. These kinds of integrals, or Gaussian integrals, they are usually not possible to calculate. But do I need to calculate? That is why they haven't asked you to find the probability distribution. They have asked you to find the probability density distribution. Yes. So that this means that you don't need capital F, you need little f. So this is not possible to calculate. I have to go back to little f by differentiating. And differentiating an integral, you can use the fundamental theorem of calculus. Yes. So this means that f of z is equal to the derivative of capital F. So let me write it with capital. So f of z is. Okay, if capital F is 0, of course its derivative is also 0. But if z is positive, f of z is this, I have to differentiate this function. So how should I differentiate this function? So the only thing I have to do is to replace x with the upper limit, but then multiply by the derivative of the upper limit as well. Yes? So this becomes equal to 1 over square root of 2 pi e to the power of minus ln of z squared divided by 2 multiplied by ln of z prime. Let me write d dz ln of z, if z is positive. Are you following or not? Yes? So what happens now? This becomes 0 if z is less than or equal to 0, and this derivative is simple. So let me write 1 over z square root of 2 pi, because derivative of ln is 1 over z, e to power minus ln of z squared divided by 2 if z is positive. Yes, is that right? And that is called logarithmic normal distribution. What is an alternative way to calculate that, which I prefer that one? That's the transformation theorem. So do you remember what should I do? I can start with little f of z directly. So this is method 2. So this becomes what? This becomes f of the old variable x calculated at x, which is expressed in terms of z. Yes? And then multiplied by the Jacobian of the transformation, but that's one-dimensional, so it becomes the normal derivative. So what is the... So you should calculate the derivative of the old variable in terms of the new variable. Yes? And this is on the safe side. By the way, what is the ingredient for being able to use a transformation theorem? Yes?
The function must be strictly growing or
One-to-one.
use absolute.
It should be 1-to-1.
Yeah.
Yes, you are right. I have to put absolute value. That's always the case. But it should be 1-to-1. But if it is not 1-to-1, you can modify it a little bit. Partition it to parts, domains that the function remains 1-to-1, and then there will be more terms added. I recently made a video with one of these questions, and I uploaded it on my YouTube, so you can see that that's the question in the book. That was a good one, which was not 1-to-1. If you don't care about 1-to-1, you will lose one factor of 2 at the end. So that's very important. But here, I am on the safe side to write this, because this transformation is a 1-to-1 transformation. Okay, so if I want to calculate this, so what should I do here? I need to calculate dx with respect to z, so I need to find x in terms of z, for example. And I differentiate it. Yes, so this becomes what? This becomes 1 over z. But then you have to also be very careful here. So what will be my support? Because the support of x is from -infinity to infinity. But what will be the support of z? Because when you do the transformation, you also have to care about the support, how the support will change, yes? X goes from -infinity to infinity. This implies that z goes from, z will be in the positive interval from 0 up to infinity, okay? So this means that this z should be positive. Otherwise, this is 0. That is part of the theorem, okay? So if I calculate this, but how should I calculate this? Fx, x in terms of z, which is ln of z, multiplied by absolute value of this one. This is very important. Now you see that it is important to care about support. But do I need absolute value here? No, because in this case, z is positive. And it means otherwise it is 0. But do you agree that is exactly the same thing that I got here, yes? So it means that this is 1 over z, and this is the normal, standard normal distribution in which you take x out and put ln of z in, which gives you this function. So this is acceptable, that's also acceptable. That's up to you which one you want to choose. Any questions here? Okay, but now let us go to the second part of the question, which is more interesting, and they have given you some kind of hint as well. Yeah, but that's not a very important hint. They are asking because they don't want to waste your time on calculating integrals. Okay, so let y sub I be IID random variables. Each one of them is uniformly distributed on the interval from 0 to 1, and z is given to be this. So let me write it here. So Zn is defined to be e to power, square root of n. And the product of these y random variables up to n and to the power of 1 over square root of n. The rest of it I don't write. I will work with these formulas. Okay? So this is Zn. We want to show that Zn converges to z in distribution. What is z? Z is the one defined in the beginning of the problem. Yes? So do you have any idea what to do? So it is, I want you to get some experience, you know. First of all, that's a product. If I want to answer these kinds of questions, including these dots, I need to use CLT theorem. Yes? This is the way at least I think. Yes? And the bad thing about this is that in CLT theorem, I need Sn. Sn is what? Sn is the sum. But here I have a product. And in the beginning of the problem, they have talked a little bit about Ln. So if you think around these lines, it shouldn't be hard to guess. Might be it's a good idea to take Ln. Yes? So I will take Ln from here. But the rest of it I want you to help me to do, okay? Do you understand why? Because that's a product. Somehow I want to use CLT theorem if you have that motivation. So this means that instead of product, you want to have sum. And that is the duty of logarithm, to change the product to a sum. So it is not that hard to see, at least it is a good thing to do, to take ln. Yes? So if I take ln, then this is a product. This becomes the ln of the first part plus the ln of the second part. But ln of the first part is what? Ln of this expression is just simply square root of n plus ln of the second expression. What will happen? This power will go to the back of ln. Then it becomes ln of this guy. But ln of a product becomes the sum of ln's, yes? Yes? Okay. But now at least I have my sum. But what I need to do, so let me give them names. Is, for example, let me call, I don't know how you want to do it. Let me call it T1. And let me call this one Tn. And I want to make it very similar to the CLT theorem so that I know what to do. So then, the sum of random variables is usually denoted by what? Sn. So if you don't mind, let me define Sn to be T1 up to Tn. Okay? And then write ln of Zn again. So it becomes a square root of n plus 1 over square root of n, what? I have Sn. I'm trying to make it similar to what I know so that I know what to do. And that's my advice for you. You have to think in this way to be able to solve the problem if the problem is hard. Yes, this is what I have. So instead of working with this complicated thing, I can momentarily work with this one, or at least think about this. The next thing I will do, I will usually go to a scratch paper or something, write CLT theorem in front of my eyes. So what should I do? Can you tell me if I want to write CLT theorem for which random variables do you think? Because here we have x variable, z variables, and we have y variables. I also introduced t variables. So I write CLT theorem for y is also good, but t variables. Yes, because I have this. I have give the name the sum for the sum of t's. Okay. So I will go to a scratch paper if you want to. So what I will do, I will write CLT theorem to see what I need and what I have. Okay, so you remember that version I just told you before. So what was that version? Do you remember? I put the square root of n here, and then I put Sn here over n, and then minus mu of what should I write? Mu of t variables, because I want to write them for t variables. I know that this will go to n of 0 and sigma t squared. Yes? Do you agree? This is the CLT theorem for this one. So, in order to understand what to do, it motivates me. You see, if you go to a scratch paper and do this, you know what will be the next step. What will be the next step? This is the CLT theorem for t variable. Yes? So, this is the general form. But I want to adapt this one even more to my problem. So what will be the next step, do you think? Now tell me something. So why don't you say that? I need to calculate mu of t, yes? And I also need to calculate... Yes or no? You see, I am guessing. That was the way I tried to think about the problem. Yes? That's exactly the way I thought. Okay? But in order to understand what to do, so why should I leave these things question mark? Because these are simple things, I can do them. Let us calculate. Might be if I spend time, it will not work at the end. But that is how it is. This is mathematics. So you have to sometimes do some trial and error as well. So I need to calculate mu of t, and I need to calculate sigma of t. Okay, so help me. I want to calculate mu of t. What should I do? This is expectation value of t collectively. When I say t, it means t is what? T is ln of y. I'm talking collectively. Yes, all of them are the same. Why they are the same? It was given in the problem that y1 up to yn are all uniformly distributed between 0 and 1, all of them. So collectively, let me call them y like this. Okay, so let us calculate this mu of t. Help me. What should I do? It is my t, which is ln of y, multiplied by the probability density function for y. Yes. This is unconscious statistician, so you can write the function, yes, but you don't need to change this distribution. You can keep the distribution of your random variable y, and then dy. In principle, I have to go from minus infinity to infinity. So let me wait for you. Is that okay? Understandable, this one? Okay, but then I want to continue. This one is given. From this information in the problem, I realize that f of this one is what? Is 1 over the difference, 1, if y is between 0 and 1, 0 otherwise. That's the limit. So instead of minus infinity to infinity, I just need to go from 0 to 1, and I replace this with 1. Yes? So I have to calculate this integral. For calculating this integral, you have to use the integration by parts, but that is why they have given you a hint. They have given you a hint here that dx, I mean that's not a very valuable hint because this is a matter of seconds to calculate this, but they have given you this piece of information. Okay, so how can I calculate this integral now? So this means that this is a primitive function for this. Yes? When you differentiate this and it becomes that, it means this is your primitive function. So the primitive function for ln of y becomes y ln of y minus y, and I have to go from 0 to 1. Is that right? Otherwise, you have to calculate the integral yourself. But then if I put 1 here, it becomes 0 minus 1. If I put 0, I have to take the limit. But that's also very simple. So the limit of y, ln of y, when y goes to 0 from the right hand side, you just use Hobbiton's rule, yes? This becomes ln of y over 1 over y, and y goes to 0 from the right hand side. If I use Hobbiton, this becomes 1 over y minus 1 over y squared, y goes to 0 from plus, becomes. So it is very simple. Okay, so this, if I put 1, it becomes 0, minus 1, if I put 0, it becomes 0, so the answer is minus 1. And when I calculated that, and it became minus 1, I was more or less sure that I am on the right track. Here I was relieved. I wasn't that relieved before this step. Do you know why minus 1 was important? And by the way, I messed up first. I got it 1, and then I was in trouble. I was close to throw it out and start all over again with a different method. I was lucky. You know that this minus 1 is very important. Why? Because what happens if this is minus 1, it becomes plus 1. And now look, multiply square root of n back. This becomes a square root of n, which you have here. And a square root of n times this one will go here. So that's exactly what I want. Here I was more or less 100% sure that this is on the right track. Okay, so how should I continue now? I need to calculate this one as well. So for calculating this one, what I need first? I need to calculate t squared. In order to calculate t squared, it becomes integral. So you know what to do. You don't need to write from minus infinity to infinity. I just write from 0 to 1. And I write t squared. T is ln of y squared. And then you know that I have to write dy. And that is the second hint in the problem. They have given you this hint that 1 ln integral from 0 to 1 ln of x squared divided by 2 dx is 1. So what is this number then? What is this number? This is the second hint. What is this? Okay, go on. Tell me something. What is that? Yes? This one is 1. So I multiply by 2. This one is more or less the same, but x is now changed to 1. It doesn't change anything, so it becomes 2. Yes? But what is the variance? So what is sigma t squared? This one minus this one squared. Yes? So this one is 2, this one is minus 1 to power 2, which is just simply 1. Okay, so I have to clean the board. Yeah, and then I will give you a rest after this. So let me just finish this problem. Okay, so let us now go and write everything from scratch paper on our exam paper. Yes, this was already on a scratch paper, so I would write it like this. So let me put a star here. So this star tells me that square root of n divided by s is multiplied by Sn over n plus 1 goes to n 0 sigma squared 2 in distribution. But then I multiply this in. So if I multiply this in, it becomes square root of n plus square root of n divided by n can be written as this. This means that this goes to n0 and 2. Yes? Do you agree with what I have written?
Can you repeat the variance thing?
Yeah, variance is 1.
Ah, yes, variance is 1. So thank you. Yeah, so fix me, please. Variance is 1. Yes, now is that right?
Yes, that's what we were supposed to show, that it approaches z.
Okay. So, but what is this one? This is not Zn itself. You remember what I'm supposed to show up there. I have to show that Zn approaches to Z. Z was defined in the problem from the beginning. That's up there. There was some, yes, here you see. My goal was to show that Zn goes to Z. Z is this guy in distribution. But be careful. Here, I was able to show that ln of Zn, which is this guy, ln of Zn, which is this guy, goes to n0 and 1 in distribution. Okay, so then can you finish the problem? So let me write it like this. Let me write it goes to x, but x is, yes, another way of writing this, do you agree, is this one? Yes, ln of Zn goes to x in distribution where x has this distribution. Yes, and that's exactly what was given in the beginning. So I think hopefully it's easy for you to go to the next step. I don't know, do we have this theorem? It is called continuous mapping theorem. So it means that if this is the case, you can apply a continuous function on both of them. Okay? That's the theorem. At least name it when you want to use it. Okay? Continuous mapping theorem. So the function.
For all types of convergence, like almost surely probability and distribution, does it preserve that?
Yes, I think so. Yes, yes. But please check it out again. Okay? So f. So which function should be applied here? The function f of x equals to exponential. Yes? This function is continuous. I already know that. So this means that f of ln of Zn also converges to f of x. Yes? So this means e to power ln of Zn, because my function was defined here, it's continuous, Yes? And goes to f of x. F of x is e to power x d. But what is this? It's just simply zn goes to ex. Ex is really z, because do you remember x was standard normal distributed, and that's exactly what we have here. Yes, because when I calculated everything on the right hand side, I automatically got n0 and 1. So this means that e to power x is exactly this z that you see here. And that's the final part. Is that right? So yeah, whenever, that is the way you have to think. Otherwise it is not very obvious what to do. Okay, so you can have break until I clean the board. Any questions regarding this?
Can you switch boards so I can check all the buttons?
Yes, yes. Okay, so let us now solve the next one. It is 2020, October 16th. I think that's the same exam. So, okay, so if you see the question, it is written that you have a sequence of random variables, IID random variables, with mean 0 and variance sigma squared. Yes. Variance sigma squared. And then y sub n be another collection of independent random variables, also independent from x's. And we also know that y sub n is Poisson distributed with different parameters. So y, you see, xi's are IIDs, they are identically distributed, but yn's are not identically distributed. They are just independent from one another and independent from all x's. Where lambda n is a deterministic sequence of strictly positive numbers such that lambda n goes to infinity as n goes to infinity. So if I want to summarize a little bit here, so what we have a sequence x1, x2. These are IID random variables. We don't know their distribution, but we know that E, for example, x1, or because they are identically all of them, is 0. And the variance of, for example, one of them is sigma squared, meaning all of them. Yes? And then what we have later, we have another sequence, y1, y2, etc. They are independent. Yes, but they are independent from one another. They are independent from all x's, but they are not identically distributed. Any y sub n is Poisson distributed with a different parameter, lambda sub n. So they are not IIDs. Okay, and then what we are supposed, and then we know something. We know that this sequence of lambda n's, which are just normal sequence of real numbers, according to the problem, goes to 0 as n approaches to infinity. No, sorry, goes to infinity as n approaches infinity. Now they have defined a new random variable, zn, to be 1 over a square. So you pick one n. For that n, you write 1 over that lambda n multiplied by sigma xi. I goes from 1 to another random variable up there, y sub n. And they have, of course, written it in expanded form, which is probably better. So I will write x1, x2, up to x y n. Yes? There are a lot of random variables involved. But don't get confused. You see, we don't know anything about these things except these. But we know that, for example, the values that each one of these random variables assume is 0, 1, 2, etc. because that's Poisson distribution. So these are integers, actually. and then you pick one fixed n. For that fixed n, y sub n is fixed, and it is an integer. Yes? And then what you do, you write x1, x2 up to x indexed with that integer y sub n. Yes? And then what you want to calculate, determine for each n the expectation and variance of zn. So let us solve the first part. We want to calculate expectation value of zn. We want to calculate variance of zn for each n. Yes? Okay, so what should we do here? There are some formulas for this. I don't know if you're allowed to just use the formulas or not, but let us try to understand how is it going now, okay? So let me try to derive it for you. So in principle, this is the problem that you had. If you have Sn, in which n is a random variable, Sn, which is x1 up to x sub n. Random variables are IIDs, okay? But n is one fixed random variable that takes non-negative integer values, and that n is also independent from x's. Okay, so I'm lazy to write them down. So these are independent from one another. N is a random variable that takes only non-negative integers, and this n is also independent from all x's. And Sn is the sum of them. But n is not fixed, it's random. Okay? It's exactly like this. So this n is playing the role of this y sub n. That's exactly the same thing. But now, do you remember, have you seen this in the book? That if you want to calculate the expectation value of this Sn, the answer turns out to be En multiplied by Ex. Yes? I'm not sure if you're just allowed to use the formulas like that. If you're allowed, of course, then that's very simple. And then I don't remember, there's another formula for the variance, but let us try to derive at least one of them. The variance would be more interesting, but let us try to see why this is the correct way of doing it. This is good because in problem solving it will help you. How should I understand that this is indeed correct?
Taylor property?
Yes, so I would write, I want to make, because n is random, I have to write a conditional probability. So I would say that this one is equal to E of Sn provided n. Yes? This is the total expectation value formula. But then do you remember I told you that if you want to understand this, you need to know this so that you can take expectation value. But do you remember I told you that this is a random variable. If I want to understand this, I will pick a value for it. Yes, I will pick a value for it. And try to calculate this one. Okay. But how should I calculate this? Sn is this one that you see here. This means this becomes what? Can you tell me what should I write? I want to calculate the expectation value of S sub capital N, provided that the capital N is little n. So what happens?
Insert.
It becomes S little n, provided that n is n. Yes? But can I take that condition off? Can I take this condition off now? That is the reason that they mentioned that n is also independent from x's. So otherwise you cannot take that off. So Sn is the sum of x1, x2 up to xn. and they have told us that this random variable is independent of all of them. So knowing that the capital N assumes any value doesn't change the probability of this random variable. This is the reason that N also being independent of X's is needed if I want to continue like this. So yes, I don't think it's a good color. That might not be able to see. Let me go back to blue. But this is not part of the solution. I mean, you can write this, by the way, part of the solution, and then you say that, okay, this is the proof of this, and I'm using this to find. Okay, but this technique is important. I want you to understand how to use this formula. It's a very nice one. So, how should I continue now? Remember, N is now fixed. N was fixed from the beginning. So this becomes expectation value. Sn is x1 up to xn. So this becomes expectation value of x1 up to expectation value of x sub n. Yes? But all of them, in general, let us say that all of them are mu. So it becomes n times, let me write n times x, if they are identically distributed. So all of them will have the same value. Collectively, I will call it E of x. Okay, so do you remember I told you what? This one, is that right? Yes. So now can you tell me how should I go back and write this? Do you remember what I told you? We calculated this one, I got this, but now I want to go back to calculate this so that I can put it here. So what is this one now? Can you tell me?
It's the same thing you're using square n.
Yes, I told you, just replace this n with the name of the random variable assuming that n, which was capital N. Yes? And then what you do, you take it with you and put it here. Okay, so therefore, I can conclude that E of Sn is equal to E. Instead of this, I put this expression. How can I continue now? This is a random variable, but this one is a number. Yes, so I can pull the number out. So this becomes Ex multiplied by En. So it's a very important formula, so it's good to remember that. Yeah, because I don't remember, let us derive it together. So for the variance, what should we do? I want to calculate also the variance of Sn. But you know that the variance of Sn is expectation value of yn squared minus expectation value of Sn squared, expectation value of Sn totally squared. Yes? I don't have any problems here. I just need to raise this one to power 2. So my problem is with this one. So at least let me show you the different proof. The proof in the book you can follow using moment generating functions and things like that. But let me also use another theorem. That's also very important because I think there are some of the exercises are using this trick as well. If I want to calculate this, what is my first step? This index is still random. So what do? I would write it as E of Sn squared n. And then again, exactly the same strategy. I would write Sn squared if n is equal to n. So how should I calculate this one now? I can write it as E S little n squared, n is n. But because n is independent of x's, it is also independent of all the variables, so it becomes just E Sn squared. So I want you to feel that we are doing something. This was a random variable and the index was random, but this one, the index is not random. Okay, so what is Sn? Sn with little n is x1 up to xn. So I calculate Sn squared. That's not hard. Okay? So this becomes every one of them squared. But plus, we remember 2 times the first one times the second one, 2 times the first one times the third one, etc., etc. So it becomes 2 x1, x2, x2, x1, x3, and then we continue until xn minus 1, xn. Yes, do you agree? That's a very standard identity. But can you let me see your combinatorics? Yes. How many terms are there?
N squared minus n.
No. N squared minus n is that if I don't have these two. I have combined them. Yes. So it means that every unordered pair that I can choose from n. So this is n choose 2.
Yeah.
Yes. Okay. So then it becomes this multiplied by that. But if you calculate this one, this is just n factorial divided by 2 factorial n minus 2 factorial, which is n times n minus 1 divided by 2. That 2 will cancel that 2. Yes. So finally, Sn squared is x1 squared up to xn squared plus 2 n times n minus 1, and then I have x1, x2 up to xn minus 1, xn. Okay, now I want to take expectation. So the expectation will be the expectation of this one. So let me skip some steps to save some time. Okay, but can you tell me what happens here? In principle, I have to write the expectation of x1, x2. But can I split it?
Yes.
Yes, because x1 and x2 are independent. So I can write it as e x1 times e x2, and it continues until, oh sorry, I made a stupid mistake, you know. Yes, I made a very bad mistake. Still, this is 2.
Yes.
This is a still 2. Yes. And then up to x n minus 1 e x n. Yes? Now I ask you, how many terms are involved? All of them are the same. Do you agree? Because ex1 is ex. This one is also ex because they are identical. So this becomes ex to power 2. All of them. But how many of them are there? Then I have n squared minus n over 2 of them. Yes? So if I want to simplify it, all of them are the same, so it becomes n times one of them plus 2 times that number is n squared minus n times one of them. Yes, I have seen this technique they have used several times in the exam, so it's good to know. I'm not saying that they have done it a little bit differently, but I think this is very easy to understand. This is just a simple algebra. Is that right? Do you agree with me or not? Yes? And now you multiply this in, so it becomes n squared ex squared, but then minus n and then positive n, I factor n out. Yes, but this one is just me, I just copy and paste it. But this one is the variance of x. Yes? So I was able to show that this expression is this one, and this is this expression. Is there any question up to here? Okay, but now I put everything back.
Question.
Yes, yes.
Yeah, but it's just because we have gotten this formula before.
Uh-huh.
Do you think it's okay for us to just use it?
Yeah, that's what I'm saying. Yes,
Yeah.
you can use it, I think. But you need to take them with you because they are not in the formula sheet.
Yeah.
Yes? Okay, but anyway, this method is good to know because they have design questions that you need to use this method. And it's not complicated. If you think it's complicated, write it for 3 variables. You see what is the pattern. Going it from there is not complicated. Okay, but I want you to know this calculation. So how should I continue now? Because the method in the book is different. It is based on another theorem. I'm not using that theorem. I want intentionally to teach you how to do this calculation. So let us see that we are not confused, no? No, good. So do you remember what I want to do? I calculated this one, but I want to calculate this one so that I can put here. So this means that Sn squared, S capital N squared, if n is n, if it becomes what? N squared E x squared plus capital N variance of x. Yes? So I wanted to calculate this. I used conditional expectation, and I want to calculate this. I told you for calculating this, it is always good to calculate it for one specific value. I did it and I got that. And then you can go to the general one by renaming little n to capital N. So I renamed little n to capital N. I have this one. Then I have to put this back in here and take expectation value to find this. So therefore, ESN squared becomes what? En squared becomes E of this expression. Yes, and then plus n times variance of x. But this is simple because this is a number. I use linearity. Variance of x is also a number. I use linearity, yes. Okay, and then finally I am done because if I want to calculate the variance, I have to calculate this and subtract them. I already did this part. This is in front of me. And now I did this one, so I just subtract them. So this means the variance of Sn is equal to what? This one. I hope that we are not that much in trouble because I think I have missed the minus sign, isn't it? Right? Anyway, so this one plus variance of x En minus that one squared, yes, which is Ex squared En squared. I have done something wrong. Can you see where?
Is that the variance really?
What? No, I have done something wrong here. Do you see that? This is correct.
I think it's 1 n squared, but that's much.
What?
Yeah, you took the square out of E of x.
Where is it? Where is it? I'm looking for it.
Second line there.
Yeah?
You removed the x squared. You took it out. Is that the problem?
Yeah, that is the problem, but I don't see where because
No.
this one is correct. That one is also correct. So this is 2 here, this is 2 outside. And then if I multiply n squared here, so this is 2 outside. And then this one is minus, and I factored that out, so that is correct. So it becomes n times variance of x. It's not wrong, is it? So I take
it's
another.
in the last line.
What?
I think it's in the last line. You copied it wrong from ESN.
Here,
No, the last line.
here.
Like,
So variance is this expression
yeah. outside
Yeah.
of expectation.
So a square is not a
Expectation of n.
Ah.
You wrote it outside. The second line.
Yes, yes. This is 2 here. This is what you mean, yes?
Yes.
Yes, that's correct now. So now if I factor between these two, so it becomes ex to power 2. This one minus that one is variance of n. And then plus variance of x en. That's variance of Sn. Okay, so that's an advice to you. If you want to use it, take it with you into your A4 paper now. So there are a lot of formulas that you need to add today. I hope that this formula I derived is correct. Do you see that it's correct?
Yes.
Did you check it? Or yes?
Yes.
Okay, good. So now, I hope that you are not confused. If I go back to the original problem, what is playing the role of this capital N in my problem? You see, that is very, very similar to this. If you know this, you really don't need to if you take this with you to the exam, of course, you just use it. But I want you to understand, do you see that this y sub n is playing the role of capital N? Because you are adding from index number 1 to index y sub n. But y sub n is also a random variable. Yes? So that is exactly your n. And the condition is also told you that these are independent. All of them are also independent there. So this means that if you know that formula, so you can calculate them. So for example, let us imagine that you have taken this formula with you, but the only thing that you have to remember is that this n can be replaced by this y sub n for any choice of n. N is fixed now. So what is EZN? EZN becomes equal to, Zn is defined in that way. So this is a constant, I pull it out. So it becomes 1 over square root of lambda n. But it becomes e of the first one of until the end. But can I want you to tell me in which in my notation, what should I write for that? What is this called now in this notation? What is this called? Sn, n is a random variable, is x1 up to xn. Compare this one with this one. This is nothing except sy sub n. Yes? So this is e of sy sub n. I use the first formula here. It becomes the expectation value. It becomes the expectation value of the random variable x collectively, whichever is that, multiplied by e of n. But in this case, capital N is yn. And I don't need to know this because what is this given? It was 0. So this is 0. So if you know these formulas, if you take these formulas with you, it would be 1 second to answer the first part. But what will be the variance? Variance, what can I do with the coefficients? When I take the variance, by the way, can I also take the variance? No, because that's Syn. But if I want to take this out from the variance, I have to raise it to power 2. Yes? So this becomes 1 over lambda n. And then the variance of S sub yn. But I have the formula in front of me. So it becomes 1 over lambda n. Ex squared variance of yn plus variance of x multiplied by expectation value of yn. So this term is 0 again, so this vanishes. Variance of x is already given to you, is sigma squared. It was given in the beginning, but I also need to calculate the variance of y sub n for that fixed n. Do you remember what was the variance and expectation for Poisson distribution? Unfortunately, either you have to have it in your memory or I don't know, because these are not in the formula sheet. You have to calculate it yourself. But what was that? We did it before. What was that? Do you remember? This is lambda n. Yes, so the answer will be lambda n sigma squared. And then there is, there is also 1 over lambda there. So it is just sigma squared. So if you knew those formulas, so it is a good thing to take them with you to the paper. So this is just the solution of the first one. Okay, now let us do the next one. We want to show that there is a random variable z such that zn approaches to z in distribution. You are also supposed to find z yourself, so z is not given. So what do you think we will do? So remember, the limit of lambda n goes to infinity, n is infinity. We want to know zn goes to z, d, we don't know this. We want to show that this is indeed the case. So how should we do that? You take it out.
It's 100%.
No, yes. Okay, so now how should I solve the problem?
CF? Characteristic function.
Characteristic function is better in this case, I think, based on
That's what I.
Yeah, yes. So it means that let us calculate phi zn at t. Yes, and calculate the limit of this when n goes to infinity to see what happens. Okay, but in order to calculate this, I know what is my zn. If you don't mind, let me stick to this convention here. Okay, so I want to write it in this form. So it becomes phi of 1 over square root of lambda n, and then multiplied by s y sub n of t. Okay, so the first thing, what should I do with this coefficient? There is a famous theorem in the book, so you can flip this coefficient inside. So this becomes s y sub n, and then you have 1 over square root of lambda n times t. Yes? But in order to continue, I have to calculate phi of t first, and then replace my t in that answer with this expression. So this motivates me to actually start calculating phi of syn of t. Okay, so I start from here. But how should I calculate this? There is a theorem in the book, yes? Do you remember? I can use it as a probability, what was it called? Probability generating functions. Yes. And then combined with phi of xt. Do you remember such a theorem? Yes. Of course, if you don't really remember this theorem, you have to start everything from scratch. But this is a very important theorem, so it's good to use it. Okay, but unfortunately for this one, I cannot go that much further. Why? Because you see that I don't know anything about x's. I only know the mean and variance. So I don't know the distribution. So there is nothing that much I can do about this point. But let us calculate this one. So, g y sub n t. So then again, I have to answer this question. But what is yn? Yn is Poisson. So if you don't mind, let me cheat a little bit to save some time. I have, you know, phi of Poisson is in the formula sheet. Phi of Poisson is this. Yes? Okay, phi of Poisson is this one, but if you want to go to the probability generating function, you need to replace e to power it with t. Okay, at least you need to, of course, you need to justify that, but let us save time because these are standard calculations and we have done it a lot during the exercise sessions. So, but if you do the calculations explicitly, it will give you e to power lambda, but in this case it should be lambda n, and then I have t minus 1. So it was good to ask if you can send an email to Lucas to ask, because this is always the case. These information are given to you in the formula sheet, and then if you want to go to g from phi, you just need to replace it with e to the power of it with t. Yes.
If the characteristic function doesn't have like e to the it,
Yes.
and it's something like, I don't know,
No, you
1
can't do that
minus
always.
lambda t.
No, you can. Okay, so you can write e to the power of it to be your capital T, and find t from ln of t divided by r and
Exactly.
replace t with that.
Yeah.
Or something like that.
Yeah.
Yes. But anyway, I hope that Lucas will accept it. If he doesn't accept, you have to start with the definition of this one. And if you want to do it, you have to use this formula for this total formula. Okay? But let us pretend that we have it. Okay? And then I want to continue forward. So this means that I want to calculate this by replacing my t with this expression. So this means that this question mark phi of synt is equal to e to the power of lambda n. Instead of this, I put phi xt minus 1. But then I put it back here to find my phi of zn. So therefore, phi of zn of t becomes equal to what? I go here, replace t with this expression. So this becomes e to power lambda n, and then I have phi x 1 over lambda n, let me write t here immediately, and then minus. So I started from this, I replaced zn with its definition, and then I knew that this constant can be flipped inside. And in order to continue, I asked myself, what is this? I used another theorem. In order to answer this, I need to know g. I cheated a little bit from my memory here, so this is g. And then I take this t out and replace it with this. I got that. And then to go back, I need to replace t with this combination, so I have it. And what is the next step? Is to calculate the limit. So I have to calculate the limit of zn t, then n goes to infinity. Okay? But because this is just a constant, the only problem that is facing for me to answer this question is to calculate the limit of the exponent. So I need to ask myself, so what is the limit of lambda n times phi xt over lambda n minus 1, and n goes to infinity. Yes? And by the way, they usually give you in a way that you are in trouble, because if n goes to infinity, they have told us that lambda n goes to infinity. But what is here? If lambda n goes to infinity, this goes to 0. What is phi x of 0?
1.
Is 1. So 1 minus 1 is 0. So this is 0 times infinity limit. So it's indeterminate. So you have to lift this indeterminacy. And then you cannot usually use the Hobbital's rule, because here, and by the way, you can use Hobbital's rule. Yes, because Hobbital's rule also works for a sequence. Yes, in this case we can, but let us do it the proper way. But in principle, you can do it with. No, we can do it with n, but unfortunately here we have lambda. If I have a sequence, I can still use Hobbital rules by replacing n with x, do the Hobbital rule, and if I get the answer, it gives me the answer to the sequence as well. But let us do it in proper way. So what is the proper way? So might be this is also good to take with you to the exam. So what was phi x if I expand that? You remember? It is 1 plus sigma. So let me choose another index. K goes from 1 to infinity. And then I have I t to the power of k divided by k factorial, expectation value of x2 power. That is the phi. And then you move 1 to the other side, it becomes this. Yes? And then you can open it up. The first one, if t is 1, if k is 1, it becomes I t and e to the power ex. Yes? And then if I put 2, it becomes minus t squared over 2 factorial, which is 2, and then you have e x2. And let me write one more term, so it becomes, the next one becomes minus I t cubed divided by 3 factorial, 6 e x cubed, and it continues. Do you agree? This is the standard expansion. But in this problem, I know what this is. Is it the same problem? Yes. It is 0. And ex squared is the variance, because ex is 0. So this is nothing except sigma squared. So this means that, let me write it here for you. So phi x of t minus 1 is this expression. Minus 1 over 2 sigma squared t squared. And then the next term will be I t cubed over 6 e to the power of x cubed. And of course, other terms will have higher powers of 3, higher powers of t. Okay? And now what is the next step? The next step is to replace t with this combination. So this means that phi x t over square root of lambda n minus 1 becomes equal to, instead of t, I put this expression. So it becomes minus 1 over 2 sigma squared t squared over lambda n. The next one becomes minus I t cubed over 6 lambda n square root of lambda n e cubed, etc. Yes? And now you see what's happening. Yes? If I multiply this by lambda n, what happens? If I multiply everything by lambda n, this lambda n will cancel itself. So it becomes minus 1 over 2 sigma 2 t2. But this lambda n will cancel, but there will be some lambda n's left in the denominator. So it becomes it cubed, lambda this, ex cubed. And of course, plus you have more lambdas in the other terms, in the denominator. And now finally I send n to infinity. What do you think I will get? If I send n to infinity, according to the problem, lambda n goes to infinity. So because lambda n will appear in the denominators, in all of them, everything will vanish, except this one, which is independent of lambda. Yes? So this means that the answer to this is simply, minus 1 over 2 sigma squared t squared. Yes? And then this was the limit of the exponent. This is constant. So finally tell me, what is this limit? N goes to infinity. It becomes exponent of this. So it becomes e to the power of minus 1 over 2 sigma squared t squared. Yes? And this is very famous. What is that? This is phi of which distribution? Normal distribution, standard normal distribution.
No, it's a sigma squared.
Oh, that's good.
Standard normal is just 1 over 2.
Yes, here should be
sigma squared.
Sigma, oh, yes, thank you. Sigma squared. So if the limit of phi is this, so what can you conclude about this? Z has this distribution. Yes? Okay, are you tired? There was one problem. Let me, because we can't finish this problem, and that was a mistake. I don't know why the examiner insisted to continue with that mistake. So that is why I'm a little bit doubtful if I am doing a mistake. So it is problem 2021, December 21st. Can you see the question? Okay, they have, the first part is very simple. They have stated the definition of the characteristic function. That is, what is that? What is the definition? Phi x of t, the definition is e, expectation of e to the power of it x. Yes? But the second question, that is very surprising for me, because I couldn't say that this is a typo. Even in the solution, I see that the examiner is continuing with the same thing. So please let me know if I am mistaken. They have given 3 phi's for you, and they are asking which one do you think can be the characteristic function of a random variable. Okay, so what are these functions? You see them, a, b, and c. So let me write them here. Do you see why none of them can be true? So the first one they have written is cosine pi over 2, pi t over 2 divided by 1 minus t squared. The other one they have written is the same thing with sine. And the other one is what? With e. So I don't think any one of them can be a characteristic function. No, because none of them is bounded. Because the denominator can go to infinity. Yes, I mean the function can go to infinity if t is very large. I mean very close to 1.
But are you sure that if...
That's a requirement, because if you have this, one thing that you know is that the absolute value of this is definitely less than or equal to 1. So none of them is correct. But, yeah, I hope that I am not mistaken. I think they should have mentioned this. All of them with plus, now it works. Yes? Of course, what I'm saying is that the wrong ones are wrong, but let me change everything to 1 plus t squared so that at least the functions are not simply seen to be unbounded. Yes, still one of them is unbounded, so that's why I can throw it out. But the other one that I know, we know that phi x of 0 should be what? 1. For example, this condition, rule this out. Because if I replace t with 0, the answer becomes 0. Sine of 0 is 0. So this cannot still be a characteristic function. But these two now satisfy the condition. So I cannot differentiate this. Because if I ask you what, if I replace t with 0, cosine of 0 is 1, this is 1, that's correct. If I replace t with 0 here, that's still correct. So this cannot differentiate these two. Which property differentiate one of them from the other with the correct one now? The boundedness. So this is a polynomial. This is an exponential. So that's not bounded. Yes, if I increase t to infinity, so it goes to infinity. So this one is not bounded, but this one is bounded. Yes? So if there is no choice for me, I mean, this should be the case. If I want to choose. But if this is 1 minus t squared, all of them are unbounded. So none of them can be. That's my suspicion. If I am mistaken, please correct me.
Just a question.
Yes.
When would cosine or a not be bounded if it was minus? When would it be larger than 1?
Ah, you mean that the limit is bounded? No, so...
When is it larger than 1 is what I'm saying.
Yes, you're right. Might be this cannot happen.
I think so. I think we checked this with like L'Hopital or something like that. I don't know.
Did you?
I think we did. I think it
So
checks
if
out.
this function, if that is 1 minus t squared, I can just draw a little bit tired to think, but if I draw this function, do you think that it will be always bounded?
I think so, yes.
If t goes to 1, it is 0 over 0, yes? And that limit exists, you mean? If I take the derivative, it becomes minus pi over 2
I
sine
think so, yes.
pi
It should be
t
fine.
over 2. So in that case, might be that's true. But I have to convince myself it is true. But at least it is not defined at 1. Should it be defined at 1? Because is this function always defined? I am a little bit confused now.
It
So
should be defined for all t.
yes, that's what I'm saying. So phi t, this is one of the things that it should be, but at least this function in the previous form was not defined for t equals to 1. If that is also a requirement, I am a little bit tired, so I cannot think properly. But anyway, okay. So let us assume that that is not a problem, but I think it should be a problem, because if I here, for which function, for which value do you think it is not defined? If all these things exist, I think, and they are not infinity, so if I replace t with 1, well, it might be, sometimes it is possible. I'm not quite sure about that, sorry. Okay, but anyway, let us assume that this is the case or the other one is the case. Yeah, because you know that the examiner continues the calculation, so in principle he should notice that this is a typo or something, but apparently my understanding is wrong. I don't know. I was thinking that phi should be defined at least for all t. Anyway. But one thing that I want to mention is the next part of the question. Can you check the question here?
It is bounded.
It is bounded.
Yes.
Yes?
It's fine.
Okay,
But
good.
it is not defined.
Yes, that I don't know.
I think according to the book, it's supposed to be defined for all t,
T.
as opposed to the moment generating function, which is stranger.
Yes, that is the reason that we bring characteristic function in the first place. Because moment generating functions sometimes exist, sometimes they don't exist. But at least phi should always exist. No, I just want to be a little bit polite to say something like this, but that is my thinking is that this should be defined. Because that was the reason that might be. But that they don't say that. They say that phi exists everywhere. Yes. Anyway. But the next part, there is one point for it. Determine whether the probability density function is a symmetric function. It means that it is an even function. Do you remember a theorem in the book? Yes, what was the theorem?
Phi is real.
Yes. So if phi is real, then that is symmetric. So the answer to this is correct, because you just say that because the characteristic function, you know that in general characteristic function should be a complex number, but sometimes the complex number turns out to be real. In that case, we know that the probability density function is symmetric. Okay, but because there is no other time that we can continue with other problems, there are nicer problems, you can continue with them. At least these problems were good to me. But there was one problem I added later, and this was this problem. It is from the course book. It's a nice problem. I want to solve it in a slightly different way so that you can also see this, and then we are done. So they have told us that xn, the very last problem, has binomial distribution n squared and n over n. But that is not binomial. Okay. Am I right? N squared m over n. And then we want to show that xn, or x, so let me write it. So it is divided by a square root xn. This is xn. Divided by square root of nn converges to n0 and 1, I think, in distribution. Is that right? Yes. And they have told you that m is positive. So, do you know the standard way of solving this? Of course, they have to mention that n goes to infinity. The standard way of solving this is very similar to the ones that we did here with phi function. Yes? But I want to teach you another alternative way. Sometimes this is possible. You know, what I want to do, there is a relation between Bernoulli distributions and binomial distributions. Okay? This will be, if you want to solve it normal way, please go home and do it normal way. If you have questions, probably I will make a video for this in the normal way. In the normal way means that you have to do these kind of calculations to calculate limits at the end. Okay? But there is a very creative way I came up with it, and I really enjoyed this. I want to share it with you. So let me write the formulas from the formula sheet. For Bernoulli, you know what is Bernoulli? Take 0 or 1, probability P. So Bernoulli P, you see this information that phi of t is p plus 1 minus p times q e to power it. If I write, let me copy and paste, I don't remember. Bernoulli, yes. Yes, it is q. Q and p. And then immediately below it, you have binomial np, and then you have phi t is equal to the same expression but to power n. So this happens another time when you have exponential function, exponential distribution and gamma distribution. So remember these tricks. Okay. So one thing is clear, that if I introduce random variables, let me introduce so from here, what can you see? You can see that if x1 up to xn are all Bernoulli and identically distributed, so that is identically distributed but independent. So can you tell me what happens for x1 plus xn by that information that I have written there for you? So from this, I take n random variables, all of them distributed in Bernoulli form. Now my question is that if I add them up, what will happen? If I add all of them, so I need to calculate phi of this, but phi of this becomes phi of the first one, multiply up to phi of the last one. Do you agree? And phi of each one of them is this. When I multiply them n times, it becomes Bernoulli. It becomes binomial. So what does it mean? It means that if that is the case, then x1 plus up to xn is binomial with n and p. Yes? So if I have Bernoulli random variables identically distributed, and they are independent, if I add them, the distribution becomes this. This should be a matter of seconds. If I give you that information, you really need to understand it very quickly. Okay? Okay, now what I want to do, I want to do like this. You know, I want to start with Bernoulli distributions, but I have to have n squared. So let me tell you like this. Can you answer this question now? If I have y1, y2, up to yn squared, if I tell you that all of them are Bernoulli, but with this parameter m over n, what can you conclude for me for y1 up to yn squared? Can you tell me what's the distribution? Exactly what I told you here. What's the distribution? It's
binomial. N squared.
It's binomial. Number of variables, in this case n squared, and then m over n. Do you agree? Okay, but now let me write CLT for these variables. CLT theorem. So what is the sum? So it becomes y1 plus up to yn squared. Do you remember? This is your Sn. I'm adding them up. Minus the number of my variables, in this case n squared, multiplied by mu of y, divided by sigma of y, multiplied by square root of the number of terms, n squared. Do you agree? This goes in distribution to n, 0, and 1. Yes? But if you see what is mu of y, if y's are Bernoulli, it is just this parameter. So instead of mu of y, I can put m over n. Now you see what will happen, and then sigma, so here let me write from here. So here mu of y is just mn, and sigma y squared is mn times 1 minus mn. These are the very standard calculations for the variance and the mean of a Bernoulli. So now everything you put it here, so see what happens. And it is actually, if you understand this technique, sometimes extremely helpful. You can go home and solve this using the standard limiting process. It is possible, and I did it myself. That's also good to know, but this trick sometimes works and is nice. So this means that y1 up to yn squared minus, now multiply mn times n squared. What happens? It becomes mn. Mn is exactly what we have in the problem. Divided by sigma y is the square root of this. And then multiply it by the square root of n squared. So this means that I have y1 up to yn squared minus mn divided by, if I multiply this in, it becomes the square root of mn, and then the square root of 1 minus m over n. Yes, I know that this goes n0 and 1 in distribution. So I didn't do any kind of limiting process. The limiting process was already done by the person who actually discovered the CLT theorem. So I used that one. Is that understandable what I'm doing? Yes?
Why could we not just put in the expected value of variance for the binomial directly?
No, because you know here you have, what I am doing is a little bit, just wait until the end, see what happens, okay? So now if I ask you, what is the distribution of this random variable? What is that? It is exactly this distribution, which is the distribution of this random variable. Minus mn is exactly minus mn. Square root of mn is the square root of mn, but this one in probability goes to where? If n goes to infinity, this goes to 1. Okay? So this means that this expression has this distribution. Yes? I am not saying that this is what I have, and I don't need to see that is what I have, because the important thing is that the distribution of this and the distribution of this random variable in the problem are the same. So if this goes to n0 and 1, that one also goes to 0 and 1. Is that clear? So this is one way of solving these kinds of problems if there are some relations. When I check the formula sheet, there is a nice relation between these two, and there is also a nice relation between exponential distribution and gamma distribution. So sometimes we can solve these problems by this trick without going through the process. If you go and sit down, it is not very hard, but you have to digest it. Any question? Do you understand at least the gesture of the problem? Yes? Yes?
So if I go from over there and know that what the expected value and the variance of the binomial is,
It does not help. You know why? No. This. So, which theorem you want to use? No, CLT does not work here. CLT you have to have a sum. Yes? CLT does not work here. But what I did, I engineered a series of random variables so that the sum that I need has the same distribution of this xn. And then I use the CLT theorem for my engineered variables. And then I would say that now I engineered them in a way that the distribution of this guy, whatever it is, has the same distribution as this one. So I can use this result. Because in convergence in distribution, what matters is not the form of the variables, is the distribution of the variables. Is that clear? Hopefully. Yes.
The dumb way of doing this would just be to take the characteristic function or the probability.
Yeah, it's not the dumb way.
No.
That is more or less always works.
Yeah.
And that is the usual way, but this is sometimes work if you are lucky, yes? Yes, but that's what I'm advised. If this is coming in the exam, because this is one of the exercises we were supposed to solve during the lesson, but I didn't have time to do it. But that was a nice problem. When I wanted to solve it in the lesson, I wanted to solve it in the usual way. But yesterday I realized, oh, there is a connection by just looking at the table. There is a connection to do this. So if this happens, that's a good way to solve the problem. Any questions? Okay, good luck. Thank you.
Ja, visst. Det är det